You ever stop and think about how a scientist in Tokyo can repeat an experiment from a lab in Toronto perfectly? It's like they're all part of this huge global conversation, but they're not all speaking English or Mandarin. No, they're speaking the language of science itself. And to get how that works, we have to start with one big question.
So how is that even possible? I mean, how do you create a system that's so precise, so universal, that literally anyone, anywhere on Earth, can use it to describe our reality and get the exact same results every single time?
Well, the answer is kind of simple, but it's also incredibly profound. Before humanity could even start to figure out the secrets of the cosmos, we all had to agree on the rules of the game. We had to create a shared rulebook.
And that brings us right to our first big idea: building that universal rulebook. And believe me, this isn't some dusty old textbook. This is the bedrock, the very foundation of all modern science.
That rulebook has a name you might have heard of, the International System of Units, but pretty much everyone just calls it the SI. This is it. This is the globally accepted standard for measurement that makes sure when a scientist says 1 meter, it means the exact same thing to every other scientist on the entire planet.
Okay, so if the SI is our rulebook, then we need to talk about its grammar. This is where we get into the real nitty-gritty of how we define our physical world with a kind of precision that is just mind-blowing. Let's take the meter, for length. How do you define it so it's always the same? Easy. You tie it to something that never ever changes, no matter where you are in the universe: the speed of light. See, by tying our definition to a universal constant, the meter itself becomes truly universal. And this number, this isn't just an estimate or a measurement, it's a definition. Scientists have officially fixed the speed of light to be exactly 299,792,458 meters per second. By doing that, they flip the whole idea of a meter on its head. It's not based on some physical ruler anymore. It's based on a fundamental truth of the cosmos. Using light to measure distance is just brilliant, right? But what about something you can actually feel, like weight? How do you measure mass? For more than 100 years, the answer was surprisingly old school. But not long ago, that all changed in a huge way. This was a massive shift. For 130 years, the definition of 1 kilogram was, and I'm not kidding, an actual lump of metal called Le Grand K, locked in a vault in France. Problem is, it could get dirty, it could literally lose atoms over time. It wasn't perfect. So they redefined it. Just like the meter, the kilogram is now defined by an absolutely fundamental, unchanging number from nature called the Planck constant. The kilogram is no longer an object, it's an idea. And that makes it perfect.
All right, with the rules of measurement locked in, the next step was to create an alphabet. Not for writing words, but for building matter itself.
And here's that alphabet, the periodic table of elements. Every single thing in the universe is made from these basic ingredients. You've got the simplest one, hydrogen. You've got carbon, the foundation of all life as we know it. And you've got precious stuff, like gold. Each one has its own unique ID card.
So let's look at that ID card. It has 3 key things you need to know. First, the atomic number. That's its unique ID number. It's what makes hydrogen hydrogen. Then you have the symbol, which is just its universal nickname. And the molar mass? Okay, think of that as the official weight for 1 standard scoop of that element's atoms. It's how we measure out our ingredients.
So we have our rules for measuring, and we have our alphabet of elements. Now we need the grammar. We need the special numbers that connect everything together and let us form sentences, or in our case, chemical compounds.
Just take a second and look at that number. That's a 6, a 0, a 2, followed by another 20 zeros. It is an unbelievably huge number. But what is it? What on earth does it count? This giant is the Avogadro constant, and it's the magical key that connects the tiny, invisible world of atoms to the world we can actually see and weigh. The best way to think about it is like a dozen, which always means 12. Well, in chemistry, a mole always means this many particles. It lets a chemist weigh something out and know exactly how many atoms they're playing with.
And yep, you guessed it. Just like the speed of light, this number is now fixed, it's exact. This official quote just shows you the insane level of precision that holds this whole system together. It's this agreement, down to the very last decimal point, that makes science a truly global thing.
And now we get to the payoff. We've got our rules, our alphabet, and our grammar. So we can finally start writing chemical stories. We can grab our ingredients, follow a recipe, and predict exactly what's going to happen.
So let's make something we all know, water. We start with our ingredients, hydrogen gas and oxygen gas. Now, the recipe isn't in some cookbook, it's hidden in these enormous tables of scientific data that have been built up over decades. By looking up the numbers, the language of science itself tells us the result before we ever strike a match.
So here's what that recipe looks like. This table shows something called the enthalpy of formation. Pure elements like hydrogen and oxygen, they're our starting point, our baseline, so we call them 0. But look at water, H2O. Whoa, it has a value of negative 285.83. And that little negative sign, that's the most important part of this whole story.
That negative value is the universe's way of telling us that when hydrogen and oxygen combine to make water, a whole lot of energy gets released. It's a downhill slide, chemically speaking. It means this reaction doesn't just happen, it wants to happen. The numbers actually predict the future. In this case, a very fiery, explosive future.
So at the end of the day, when you look at tables full of data like this, don't just see a bunch of boring numbers. See a dictionary. See a rule book. See the foundation of this incredible shared human project, built by generations of curious people from every part of the world, all trying to read the same book, the universe itself.
What you should take away from all this is that science works because we all agree to speak the same language, a language that's built on the unchanging, fundamental constants of our reality. This isn't just data. It's the language the universe is written in, and we are just now getting fluent. So the real question is, what amazing new things will we learn to say next?